So, what is the Big Bang, and please explain how it works?
Humans have wondered where the universe came from for thousands of years. Well, let's go back to the 20th century. There was a major advance that led to the formulation of the Big Bang theory. Now, this starts with the observation of an American astronomer by the name of Edwin Hubble. So this was 1905, 10, something like that. What Hubble observed with his brand new telescope, he had a very big telescope built, and he was looking at the distant galaxies. What he observed was that there are lots and lots of galaxies in the universe. The ones that are furthest from us are actually running away from us, we people on Earth. And the further away they are, the faster they're running. Now, I'll come to this later as to how he knew the galaxies were where they are, how far they are away from us, and also their speed with respect to us. But now just think for a moment if his observations are indeed correct. Well, suppose you have a bomb. Now that bomb explodes and there's a shell around it. The fragments of the shell move out. The center remains where it is. Now, of course, in the case of a bomb, it's easy to measure the speed of the fragments. What do you do in the case of the universe? Well, Hubble used the following method. He said, I know what light from a certain atom looks like. I know its color. Now, if that atom is moving away from me, its light gets slightly reddened. That's called the redshift. Then he had a method of finding out how far these stars are, these galaxies are, and it's a little technical to go into that. Let's let that be. So what he did was actually plot the speed of galaxies versus their distance away from us. And so if you make a graph like this, those galaxies, so if this is distance, then, and this is speed of the galaxies running away from us, then what Hubble observed was that galaxies are more or less like this. Now imagine that you were to take a video of the beginning of the universe. You see that the galaxies are running away, and those which are furthest away are running away the fastest. Now imagine you run the video backwards. So your galaxies then converge, and ultimately they come to one point. That time at which the universe was a point is the creation of the universe, it's the beginning of the universe. That's what's called the Big Bang. Now this sounds pretty good, but look, you can ask the question, obvious question. We're watching this from Earth. What if somebody watches it from some other part of the universe? Would she or he see the same thing? And the answer is yes, because why should we be so privileged? But then you can't understand this in normal terms. This is where Einstein comes in. The equations that I told you that Einstein had derived, which require the curvature of space and time, those are absolutely essential to understanding why a person on the other side of the Milky Way would also see an expanding universe, would also see the galaxies running away from us, and he would see Hubble's law, what I wrote down over there. Okay, now this seems to violate common sense, but let me say that it doesn't. Let me explain. So suppose you have a balloon, and that balloon is being blown up. And suppose on the surface of this balloon you have little ants, the little squiggly things, crawly things. Every ant can look at every other ant and see that ant running away or moving away as the balloon gets blown up. The more the balloon gets blown up, the further away that ant's neighbor is. And of course, it doesn't privilege any one ant over the other. So this then tells us that we actually live in an expanding space-time. Of course, you could ask, you could say that's a nice story. How do I know that it's actually right? And here we have to have solid experimental evidence. Well, one of the evidences is, of course, that is Hubble's law. But there are two other very spectacular pieces of evidence. One is that with the Big Bang, we are able to predict what was there in the beginning in terms of matter. Well, the universe began primarily with hydrogen. So hydrogen comes it comes at a later epoch, but that hydrogen is not the only thing in the universe. That hydrogen, because of the stuff it had in it, the fast-moving protons and electrons, from that we get nuclear reactions, we get small amounts of helium, lithium, beryllium, and then the heavier elements get fewer and fewer. So, in other words, the distribution of elements in the universe, as predicted by the Big Bang, turns out to be exactly what astronomers see. There's also another very strong piece of evidence, and that is when this universe expanded, it went from its early phases when it had basically just quarks and electrons in it to a later stage. At one point, the light that was in the universe managed to decouple, managed to escape the clutches of matter. And we can see that light today. It's a very famous accidental discovery in 1960 something, and it led to a Nobel Prize in Physics being awarded. So today we have experimental observational evidence in the form of Hubble's law, in the form of distribution of elements, and in the form of the background radiation that we see today. So that's why we are pretty certain that the Big Bang is how the universe began.